हेलो एंड वेलकम टू ऑल ऑफ यू। कैसे हो आप सब? गुड इवनिंग। अरे कोई तो बोलो भाई। सो माय वॉइस इज क्लियर टू यू ऑल? द स्क्रीन इज विजिबल टू यू? एनी इशू विद द स्क्रीन एंड वॉइस? अल्फिदा जेएनवी, सतारा जेएनवी, अहमदनगर स्टूडेंट। ओके, गॉट इट। Yeah, I am very fine. Thank you for asking, JNV and students. How are you guys? तो सबसे पहले तो मेरा एक सवाल है आप लोगों से। सभी से ही मेरा एक सवाल है। तो वन क्वेश्चन। मजा आ रहा है जिंदगी में? लाइफ इज गोइंग वेल और नॉट? कह रही कि सर अभी तो पता ही नहीं है लाइफ का कुछ। ओके। So let me just start recording. Okay, so good evening to all of you once again. I welcome you all in this session of electrostatics. This is the lecture number 4 that we are going to cover today. Okay. In the previous lecture, we have gone through in a very detailed manner. We have gone through on the Coulomb's law. Okay, between the forces. Got it? And in the Coulomb's law, we have also seen what is the effect of the medium. If the charges are placed in the medium, then what effect then they cause? Okay. The force will reduce or increase. And what is the force applied by the medium itself? है ना? So today we are going to see that how this force came into the action. ठीक है ना? Got it? So that is the goal of today that we are going to learn. But before that, we will see the continuous charge distribution. ठीक है? So let's move on to the very first slide. Continuous charge distribution. Let me build the base for you. अभी तक हमने जो पढ़ा है that is the point charge. ठीक है? And 2 point charges के बीच में there will be a separation. Suppose here this is Q1, this is Q2, this is Q3, this is Q4. So there is a lot of separation in between them. Got it? But what if I take these charges very close to each other? Q1 here, Q2 is also here, Q3 is also here, Q4 is also here, which means there is nothing to find in between them. The spacing is such narrow or such complex, means such compact spacing we have given, we cannot take any other charges in between them. Okay? So that particular distribution of charge is termed as the continuous charge distribution, which means if you go through that distribution, you will never find a gap in between the charges. Okay. For example, this is a road, let's say metal road, and you have provided a charge Q. So we know that due to the conduction, ये जो सारा चार्ज है इसकी सरफेस पे फैल जाएगा. Now you cannot see where is the spacing between the charges. So these types of charge distribution is termed as the continuous charge distribution. Here, if you take this cross section, this is also having some charge, है ना? If you take this cross section up to this is also having some charge. This cross section also having some charge. Even if you take a very small length, which is the differential length, that is dx, तब भी इस पर्टिकुलर स्ट्रिप पे देर इज सम चार्ज विच इज टर्म्ड एज dq. ठीक है? सेम वी कैन डू फॉर अ शीट. दिस इज अ प्लेन, दिस इज अ लीनियर लेंथ. ठीक है? ओनली वन डायमेंशन. इस हाइट के बारे में वी आर नॉट इंटरेस्टेड व्हेन वी आर टॉकिंग अबाउट द लीनियर डेंसिटी और लीनियर लेंथ. ठीक है ना? तो ये थिकनेस हमारे लिए इतना वैल्यूएबल नहीं होती है जितना कि length. But if you're talking about a plane, so both the dimensions are valuable to us. ठीक है ना? And suppose we give a charge to it, so charge is all spread on it. पूरी की तरह पूरा फैल जाएगा ये. ठीक है ना? That particular distribution is also termed as continuous charge distribution. Another is when you give a charge to a sphere. ठीक है? So in that case, ये पूरा चार्ज जो है इसकी वॉल्यूम पे आकर के फैल जाएगा. So that particular distribution is volume charge distribution. Now let us understand these all distribution in a detailed manner. ठीक है? So first of all, this is the definition. What is the continuous charge distribution? That is a system in which the charge is uniformly distributed over the conductor. ठीक है ना? Uniformly distributed is a very important word here. You have to take a note of it. Because when we are solving questions, we will be dealing that when charge is not uniformly distributed, we will also be dealing with that case. And in JEE, you can expect these types of questions. But in NEET, uniformly distributed is sufficient. Now, as I have already told you, that there are number of charges are present, infinite number of charges. And they are closely packed. Means उनके बीच में बिल्कुल भी आपको स्पेसिंग नहीं दिखेगी. Very minute spacing in between them. ठीक है? So that is also a property of this continuous charge distribution. And actuality यही है. You will never find a point charge. You will find always a continuous charge distribution. ठीक है? Got it? Because if you are going to buy a wire na, so a wire is also considered as a linear rod, and that is also having distribution of charge uniformly on the surface. So a small wire is also containing a continuous charge distribution. So that is why it is important to learn. Okay? Because in practical life, you will never find a point charge freely liberating or freely walking and talking. Okay? So in practical life, you will see in real life examples, the continuous charge distribution is dominating. Okay? Although it is a very easy concept to learn. Now, there are types of continuous charge distribution. I have already given you a hint that what can be the possibility. So first of all, the linear charge distribution is there. Then the surface charge distribution is there. And in the last, we have the volume charge distribution. By the name itself, इनके नाम से ही क्लियर है ना? Linear charge means we have distributed the charge in a line. ठीक है? और line का मतलब क्या हुआ? There will be a line, which means another dimension we are not considering. We are only considering the charge in a single direction. ठीक है? So अभय लाडवा अपनी नींद से जग जाओ, because it is not night, it is evening. ठीक है? तो थोड़ा मुंह वूह धो के आओ अपना. You'll get to know दिन है या रात. So linear charge में क्या है? एक dimension is very greater and another dimension are not considerable. If we give the charge to this, so this charge will distributed over a line. So that is why this distribution is termed as the linear charge distribution. Okay? Another thing is when you take the surface, when you are taking the surface, now you are just introducing a new dimension. That is height or thickness, whatever you can say. Okay? So when we are only dealing in one dimension, the charge distribution is linear charge distribution. When we are dealing in two dimension, the charge distribution is this surface charge distribution. Okay? And when we are dealing the three dimension, so that will be like a cube also. You can take the example of cube. So this is the distribution which is associated to the volume. ठीक है. Now the linear charge distribution you can say here. This is a road. Positive charge Q is distributed to it, and it will uniformly spread over the surface. Over this what? Over this road, and this road has a length L. ठीक है. So total charge कितना हमने किया दिया है इसे. Total charge given is Q. Now if I talk about कि this particular length पे total length is capital L. Okay. Now अगर मैं आप लोगों से पूछूं what is the charge distribution up to this length, what is the charge distribution up to small l length, how much charge this small l length consider, so can anyone calculate it? It is very simple. You have did in the elementary level of mathematics. Suppose there are 10 mango. ठीक है. 10 mangoes having a price of 120 rupees. थोड़े महंगे हैं पर अच्छे हैं. Then if I want to ask what is the price of one mango, can anyone tell? Any one of you? What is the price of one mango? Very good, JNV student. So it will be 12 rupees. Any other student are not interested in this, huh? What about you, JNV Satara, Alfida, JNV Ahmednagar student, Ashwin, JNV Shimoga, Jyoti, JNV Savarkanta, and this user, I don't know the name. What about you guys? This class is for you also, na? So you need to be responsive. Now I want the response from each and every one of you. Then I will proceed. Batao, what is the price of this one mango? Everyone. JNV Satara, JNV Ahmednagar, Alfida. Write it in the chat box. Okay, Pratishpa is here. Very good. What about you, Ashwin? JNV Bhavnagar, what about you? Class 12 students. Okay. So next time, I do not want me to take name of individual student. Then you are going to answer. If I'm asking a question, then you have to answer. It's your duty. Okay. So same way, may if you want to know the price of one mango, then it is easy to calculate whatever the number of mangoes is. What is the price of 120 mangoes then? Tell me. Price of 120 mangoes. If one mango costs 12 rupees, what is the price of 120 mangoes? Very good. Come on. Answer. Every one of you. ये तो काफी सिंपल है. It's so simple. JNV Ahmednagar student, are you there? JNV Satara, Alfida, अश्विन. देखो फिर से मुझे नाम लेने पड़ रहे हैं, है ना? JNV Shimoga. Answer now. If I'm answering, if I'm asking some question, answer. This is the in your benefit. If you answer quickly, na, then we will save a lot of time. ठीक है? And then we will use that time some fruitful conversation. Very good. So answer is 1440. You just multiply this 122. Now in this case also, if entire length L is no JNV Bhavnagar, it is not Q by 4. I will tell you. Now L length पर total charge कितना है? कैपिटल Q. तो यूनिट लेंथ पर चार्ज कितना होगा? मींस वन लेंथ पर. वन इज द यूनिट लेंथ. इट इज Q अपॉन L. ठीक है. गॉट इट. दिस यूनिट चार्ज लेंथ इज टर्म्ड एज लैम्डा. इसी हम किससे लिखते हैं? लैम्डा से. एंड दिस चार्ज पर यूनिट लेंथ इज टर्म्ड एज द लीनियर चार्ज डेंसिटी. लीनियर चार्ज डेंसिटी. Now, whatever the length is given to you, you can calculate the charge now. So, how much length का charge we have to calculate? Small l. Small length का charge कितना हो जाएगा? Let's say Q is equals to what? Take this lambda, which is Q by L, and multiply the length in which you are interested. So simply you can say it is lambda into small l. ठीक है? Where this lambda is linear charge density. Same we are going to do for surface charge density, and same we are going to do for what? Volume charge density. So here you can see here the linear charge density is given by lambda. Lambda here is what? dq, charge divided by length. So charge per unit length is termed as linear charge density. So now you can easily calculate whatever the length is given to you. Okay. So for a uniform charge distribution, you can apply this formula that integration 0 to q dq is equals to 0 to L lambda dl. Suppose the charge distribution is not uniform, means lambda is not uniform. Not uniform. Then in that case, the function is given to you कि लैम्डा किसके अकॉर्डिंग वेरी कर रहा है. लैम्डा इज अ फंक्शन ऑफ एक्स और फंक्शन ऑफ क्यू इटसेल्फ. whatever is the function, it is given to you. Then you put the value of lambda here and integrate it. ठीक है ना. But if lambda is uniform, which means it is a constant quantity, so you can take it out from this integration and then integrate 0 to L dl. dl is the 0 to L dl, which means total length. So again you will get this formula. ठीक है. Now Q is equals to lambda into L. देखो Q क्या था? टोटल चार्ज था. So what we have did, we have taken lambda charge per unit length and total length से जब इसे मल्टीप्लाई कर देंगे तो that is why we are getting this Q. यहां से भी आप इसे समझ सकते हैं. This capital Q is equals to what? यहां से ही अगर आप इसे देखें तब भी आप इसे ऐसे ही कैलकुलेट कर सकते हैं. Q is equals to lambda into L. I hope this is clear to you. So here this is important कि lambda here is equals to Q upon L. ठीक है. इसकी यूनिट क्या होगी? कूलम पर मीटर. नाउ नेक्स्ट में सरफेस. सिमिलरली सरफेस के लिए भी हम सेम कॉन्सेप्ट से गो थ्रू करेंगे. सो वी हैव कंसिडर अ वेरी स्मॉल एरिया हियर डीए, एंड इस डीए एरिया पर व्हाट इज द चार्ज? we have considered very small area of dA and the charge over it is, अगर एरिया बहुत स्मॉल है तो चार्ज भी बहुत स्मॉल होगा. by considering a very small area, then charge is also very small. So in that case, charge here is, let's say, D capital Q. Total charge is Q. So when we divide it, same concept we can use that we have used for one mango n. ठीक है. So entire area पर how much charge is distributed? Capital Q. So unit area पे how much charge is calculated? Distributed, sorry, charge per unit area. Now this charge per unit area is nothing but the surface charge density. So here is also, if you will see, this is charge per unit area. So what is this? This is the surface charge density. Okay. Again, with the help of it, you can calculate the total charge on the surface or total charge on any particular area. Got it? So this is the unit of this sigma is given by coulomb per meter square. ठीक है. I hope this is clear to you all. Any kind of doubt if you are having in this, you can ask me anytime. Now we have this pair. Now the entire charge is distributed over the over, not over the surface, over a volume. So again, if V is considering capital Q charge, so unit volume में कितना charge होगा? 2 upon V, and that is termed as rho. Rho is nothing but the volume charge density. We can do it for small charge also. So we will consider a very small volume here. Small volume means very small sphere from this bigger sphere, which is having a charge dq. अब वॉल्यूम जितनी कम है तो चार्ज भी उतना ही कम होगा, है ना. Lesser the volume, lesser the charge. So rho is nothing but the charge per unit volume. So this is also termed as volume charge density. With the help of that also you can calculate the charge over a volume. Okay. Where Q is the uniform charge distribution over the system and V is the volume of the sphere. इसकी यूनिट क्या हुई? कूलम पर मीटर स्क्वायर. बिकॉज डिनोमिनेटर में क्या है? वॉल्यूम है. वॉल्यूम इज नथिंग बट LBH. सिंपल फॉर्मूला बाय कंसीडरिंग अ क्यूब हियर. L, B और H. L की यूनिट क्या होती है? मीटर, मीटर एंड मीटर. When we multiply these three, it will become meter cube. Okay, got it? Just give me a second. One of the student that is trying to dismaintain the decorum of the class, you will get to know. ठीक है ना. Okay, so now I'm going to ask a question to all of you. Is there any problem in this? Any kind of issue? समझ में आ गया सबको? Everyone, please response. Okay, so JNV NM student has answered. Again, I'm not going to take any of the name again. Answer rapidly. If anyone has any kind of doubt, please ask. Otherwise, we will move forward. So is this clear to you all? Once again. Okay. So I'm considering that there is no doubt to anyone. It's a very simple topic also, है ना? Now, the topic that we are aiming today is electric field. Electric field में what is the learning objective that we have decided today? Is the electric field due to a point charge, electric field due to the multiple charge, and electric field due to the lines. ठीक है? Now, electric field due to a point charge. So first of all, we have to learn कि what is a electric field is. ठीक है? आपने कल पढ़ा था. We have studied yesterday that if there are two charges in a system, just a second. If there are two charges, Q1 and Q2, okay, so there must be a force of attraction or repulsion in between them based on the types of charge. If the charge is positive and positive, they will feel a repulsive force. If the charge is positive and negative, they will feel the attractive force. Okay. But what if here is the charge Q1, here is the charge Q2, there is a lot of separation in between them. ठीक है, lot of separation R. Then what is the vector? Q1 यहाँ पे है भी नहीं, Q2 की जगह पे. Who is applying the force on Q2 and how the force on Q2 is applied by Q1? सोचने की बात है ना. ठीक है. It is same as when we considering the earth, suppose this is the earth, when an object is here at its height h, ठीक है, so earth is applying a gravitational force to it, and what is that? F is equals to g m1 m2 over r plus h whole square. In same way में coulomb's force is what? Replace g with k, m with q, and the distance will see r square. ठीक है, that is why in the orientation session I have said to you कि gravitation and electrostatic is same, only need to change the q1 replaces by this mass is replaced by the charge, that is the only possible change. ठीक है, so we know that कि ग्रेविटी को फील करने के लिए वी शुड नॉट ऑलवेज बी ऑन द अर्थ. अगर आप अर्थ से थोड़ा ऊपर भी हैं, यू एट अ सम हाइट, देन आल्सो यू कैन फील द ग्रेविटेशनल पुल, है ना? गॉट इट? इफ यू ड्रॉप एन ऑब्जेक्ट, ऐसा नहीं है कि अगर आप किसी ऑब्जेक्ट को बिल्कुल सरफेस पे टिकाओगे तभी ग्रेविटी फील होगी, नहीं. इफ यू ड्रॉप द ऑब्जेक्ट इट विल फॉल डाउन, एंड व्हाई इट इज फॉलिंग डाउन? बिकॉज ऑफ द ग्रेविटी. But there is a space between them, which means whatever the force the gravity is applying can applied through over a distance, so no need to make the contact. That is why these types of forces is termed as contactless forces, okay, or non-contact force. So how scientist has explained this phenomena कि without even the contact, अगर मेरे पास ये पेन है and I want to open this, so I have to apply the force by making the contact. But gravity is like कि अपने आप ही सब हो रहा है, ठीक है ना? And same is happening for the electrostatics. So what is happening then? The explanation here is given by the electric field concept. So always remember, whenever a force is non-contact, it will create its field. Okay? Suppose we have a charge q here. So what this charge will do, depending on the magnitude of its charge, कोई चार्ज कितना ज्यादा है कितना कम है, सिमिलरली कोई मास कितना कम है कितना ज्यादा है, द अट्रैक्शन ऑफ अदर मासेस विल डिपेंड्स ऑन दैट. ठीक है, अगर अर्थ की जगह में जुपिटर को ले आऊं तो जुपिटर विल हैव मोर ग्रेविटी बिकॉज इट बिगर देन अर्थ. सेम वे में if I taking a charge of 1 coulomb and I'm taking a charge of 1000 coulomb, so 1000 coulomb will apply more force because it's more in magnitude. So same way में this capital Q charge, suppose what it will do, it will create a field around it. ठीक है ना? This is termed as electric field cloud or simply electric field. Now suppose there is another charge Q, the very small charge. When it make the contact, not the contact, when it enters in the field of Q, this particular field which is given by E, this field is applying the force on this charge. अब सबको clear है कि how this non-contact force is working? This particular charge, whatever the charge is, creates a field, and that particular field is applying the force on the other charge particle. It will be attractive or repulsive based on the nature of other charge particle. ठीक है? Suppose this is a positive charge and this is a negative charge, you have make the contact. So the field will try to grab it, attract it. So the force will be attractive. If this charge is also a positive charge, so field will try to repel it. ठीक है? Got it? Now how to know the magnitude of it? How to establish the relation? What is the electric field is equals to? So for that, we are actually talking about the amount of force that this charge particle is applying on this charge particle. ठीक है? So F is equals to K capital Q small q upon R square. Got it? Now If you take this q here, it will become f upon small q is equals to k capital Q upon r square. Now, अब आप सोचो, this is same as the linear charge density we have given, है ना? So if this particular charge you can consider a unit charge. यूनिट चार्ज क्या होता है? जिसकी अपनी कोई फील्ड नहीं होती, अपनी कोई फील्ड सिग्निफिकेंट फील्ड नहीं होती। मतलब जब ये किसी दूसरे चार्ज की फील्ड में एंटर करता है तो इट विल बिहेव कि मेरे पास अपना कुछ नहीं है, तुम ही हो जो मेरे हो, ठीक है ना? तो वट एवर इट विल फील either attraction or repulsion, it will be because of the other charge. इसकी जो फील्ड है वो दूसरे चार्ज की फील्ड को डिस्टर्ब नहीं करती, which means that the force that it will feel is a pure force which is applied by the other charges. ठीक है, जिसकी फील्ड में वो है. So when this charge will become unit charge, so this formula, if you will see, this F upon Q naught, Q naught is a unit charge, so it will become what? This is force per unit charge, which means this charge has a magnitude of 1 coulomb. Forces have a unit of Newton. So this particular quantity is Newton per coulomb. Now, suppose I have a 100 coulomb charge particle, which I bring in this field. So what is the force applied on this? So we know that force applied on a 1 unit charge is this F upon Q. तो 100 कूलम पे कितना होगा बताओ? F upon Q is for what? यूनिट चार्ज पे, 1 चार्ज पे. सो 100 कूलम पे कितना होगा? जस्ट मल्टीप्लाई इट विद 100 एंड यू विल गेट द वैल्यू ऑफ what? The force. So this particular quantity F upon Q is termed as the electric field. Now let us understand it in a detailed manner. So we have considered a charge q that is placed in the vacuum. ठीक है, ये रहा चार्ज. क्लैरिफाई इट मोर. हमें पता है कि if this charge is positive, so it will feel a what? A repulsive force, and that is try to get away from this. ठीक है, just a second. Okay, दोनों सेम चार्जेस हैं, प्लस प्लस है, so the force will be repulsive force. Okay, now अगर हमने चार्ज q को रिमूव कर दिया, देयर इज नो चार्ज, ओनली दिस कैपिटल Q चार्ज इज देयर, तब सराउंडिंग में क्या बचा? कुछ है सराउंडिंग में? यहाँ यहाँ कुछ है? एनीथिंग? यू कैन सी एनीथिंग? मुझे तो नहीं दिख रहा. एनीवन? किसी को कुछ दिख रहा है? बताओ. जेएनवी एनएम स्टूडेंट? मुझे भी नहीं दिख रहा. अहमदनगर, सतारा, ज्योति, बताओ. अश्विन, प्रत्युष्पा, जेएनवी भावनगर. आज तो आप बिल्कुल भी रेस्पॉन्स नहीं कर रहे हो. जेएनवी भावनगर, व्हाट इज हैपेंड? व्हाट हैपेंड? जेएनवी शिमोगा, टेल मी. ओके, बस यही कमी करते हो आप लोग. ओनली जेएनवी एनएम स्टूडेंट इज आंसरिंग. ओके, गॉट इट. सो we are having nothing. So because of which, if I get it away again, take a look. यहाँ पे एक चार्ज था तो इससे फोर्स लगा, ठीक है, इट इज फीलिंग अ फोर्स हियर. बट व्हेन आई रिप्लेस द remove the charge, there is nothing in the surrounding. Then who is applying the force? Charge is here. There is a lot of separation in between them. Who is applying the force? The electric field. I've already explained it to you. Okay? So same question it is being answered. If there is nothing at point P, then how does the force act? And we place the charge Q at P. So it is because of this particular charge will create a field around it and then it applies the force. Okay? Now this is a charge Q. We have taken this test charge. Test charge you can also consider a unit charge. And I have already, very good JNV Shimoga, field is applying the force. Very good. So this test charge is also that charge which has no field. Which has no field. Always remember that. Okay? So electric field is given by the force per unit discharge. अब इस चार्ज का तो कुछ है ही नहीं अपना, पर यूनिट ही चार्ज है ये तो 1 unit charge. So this particular value is termed as force per unit charge. Now whatever the charge you have given, you just multiply it with E, you will get the value of force. Okay? Now force here is 1 upon 4 pi epsilon naught Q into Q test charge divided by R square, R cap, if you are taking in the vector form. Now, the electric field will be due to a point charge is equals to 1 upon 4 pi epsilon naught Q upon R square. This is very important. This is the expression for a point charge of electric field due to a point charge. ठीक है? इसकी SI unit you need to remember that it is Newton per coulomb or volt per meter. ठीक है? इलेक्ट्रिक फील्ड की डायरेक्शन से एक क्वेश्चन जरूर आता है इन जेई एंड नीट. यू कैन एक्सपेक्ट अ क्वेश्चन फ्रॉम द डायरेक्शन एंड एक क्वेश्चन जो आएगा वो डिफरेंट फिनोमिना से आएगा व्हेन वी डीलिंग विद मल्टीपल चार्जेस एंड द अदर सिचुएशंस. ठीक है? नो. डायरेक्शन जो होगी इलेक्ट्रिक फील्ड की ऑलवेज टुवर्ड्स द फोर्स. सो आई विल आस्क यू अ क्वेश्चन वेरी रैपिडली हियर. सपोज दिस इज अ पॉजिटिव चार्ज. ठीक है? सो if another positive charges came in the field of it, what is the direction of field? This way or this way? This has 1, this has 2. So direction will be 2 or 1. Very good. Very good, JNV Anam student. JNV Shimoga, now it's your turn. JNV Ahmednagar, Satara, Jyoti. And the guys who is watching us through the YouTube, you can also answer. What about you, JNV Shimoga? Alfida? The more you will participate, na, the more you will get conceptual clarity. So it's up to you if you want that or you don't want. Okay. So the answer is this, because here the force की जो direction होगी, that particular direction is the direction of electric field, and these charges are same, so it will feel a repulsive force. So direction of electric field will be also repulsive. Got it? And if it is a negative charge, so option 2 will be correct. Now, for a positive charge, always remember positive point charge के लिए जो field होगी, suppose this is a point charge and positive, तो इसकी जो field होती है, is it like this, radially outward. Okay. So we will consider the field by this charge particle, positive charge से जो field होगी, that will be radially outward. For negative charge, it is radially inward. ठीक है? So for negative charge, it is radially inward. Now this is a challenge for you. Very simple question. Try to solve it. There is the magnitude of electrostatic force experienced by a charge of 1 into 10 raised to the power minus 6 coulomb is 1.5 into 10 raised to the power minus 3 Newton. Now find the magnitude of electric field at the position of the charge. चलो try to solve it, everyone. Very easy question, just a piece of cake. So how do we start it? देखो, 2 is given to you, 1 into 10 raised to the power minus 6. ठीक है. फोर्स जो इस पर्टिकुलर चार्ज पे लग रहा है दैट इज 1.5, 10 raised to the power minus 3 Newton. Now we know that electric field is nothing but force per unit charge, or you can say force is nothing but Q into electric field, है ना. Force is given to you 1.5, 10 raised to the power minus 3. Charge is given to you 1 into 10 raised to the power minus 6. E. So E here will become what? 1.5 into 10 raised to the power 3. Because 6 will come down, and when this go up, it will become 10 raised to the power plus 6. Plus 6 minus 3 will be 3. So it is 1.5 10 raised to the power 3 volt per meter, or और another unit is Newton per coulomb. ठीक है. This is the answer. Very simple, है ना. So I hope you got it. Now the same solution is given here. The next question. A water droplet of mass 10 mg and having a charge of 1.5 10 raised to the power minus 6 coulomb stays suspended in a room. Now, what is the magnitude of electric field in that room and what is its direction? So here we have this spherical water droplet, and it is saying that it is suspended, which means it is not moving anywhere. ठीक है ना. So if it is not moving, the weight will be acting downward definitely. So there must be a force which is countering this mg force. That will be the Coulombic force that is applied on this charge, because it has a charge. How much? 1.5 10 raised to the power minus 6 coulomb. ठीक है. So we can say that this F is equals to mg, and this F is the QC, Coulombic charge. We can write this FC as 2 into E is equals to m into G. Now so Q is given to us 1.5 10 raised to the power minus 6. Electric field we are interested in. Mass is 10 mg. देखो, ये 10 mg ना वेट है टोटल. ठीक है. So which mass is 10 m. So it is 10 m into g. ठीक है. Now you can easily calculate it. Electric field will become 10 m into 10. g की वैल्यू भी हमने पुट कर दी है 1.5 10 raised to the power minus 6. Now this 6 will go up. This 10 into 10 will become 100, or 10 raised to the power 2 plus 10 raised to the power 6. It will become 10 raised to the power 8, and it will become m upon 1.5. ठीक है. Now whatever the value of mass is given to you, you can now calculate it and easily do this. ठीक है. Now electric field due to multiple charges. If anyone has any kind of doubt in the previous question, you can ask right away. Huh? Now the same that we have did for Coulomb charge, that the force due to multiple charges, the same we are going to do for the electric field. इलेक्ट्रिक फील्ड और फोर्स में सिर्फ एक चार्ज मल्टीप्लीकेशन का ही डिफरेंस है. ठीक है ना. देयर इज नथिंग टू मच डिफरेंस इन बिटवीन दिस फोर्स एंड द इलेक्ट्रिक. ठीक है. Force, you can say it is the amount that is having for complete charge or particular value of charge. But this electric field is the force that is being applied on a unit charge. अच्छा, direction. Yeah. So direction आप easily guess कर सकते हैं. If electric field is going this way, which means whatever be the other charges, it is being repelled. ठीक है, so direction will be opposite to the gravitational field. So suppose here is the another charge particle by which it is feeling this force, so which means the electric field will be repulsive in nature. ठीक है ना? Got it, everyone? Okay, very good. Now, electric field due to the multiple point charges. So it is same that we have did in the previous class. In the previous class, we have seen if there are Q1, Q2, Q3 different charges. So the force that is filled by this Q1, I am denoting it as F1, is the vector sum of the force applied by the other charges. ठीक है, तो सेम वे में यू कैन राइट F1 as Q1 sorry Q1 into E1 vector. It is Q2 into E2 vector plus Q3 into E3 vector. Now, but this Q1, Q2 and Q3 will not come here. This E2 is the point, it is for the point charge. So this all will replace the value as point charges. So we can say this will cancel out. So electric field for this charge is equals to the vector sum of other point charge electric field. ठीक है, यहीं पे भी आपको सेम ही बताया जाएगा. देखो, so we have different charges here, Q1, Q2, Q3 and Q4. ठीक है, now this is point P, particular point हमने consider कर लिया. Now there are multiple charges, Q1, Q2 and Q3, Q4 are there. These are the position vector with respect to this point P, जिसके about हमें electric field निकालनी है जिस point पर. ठीक है, so these all are the same nature. Suppose these are all positive because electric field is away from them. So definitely these charges will be positive in nature. So this is the field by E1, radially outward, radially outward, radially outward, and it is also radially outward. So we can say that the net electric field at point P is E1 plus E2 plus E3 plus E4. And always remember that the electric field of this charge will not be disturbed by the electric field of this charge. ठीक है, बिकॉज इस चार्ज की अगर आप इलेक्ट्रिक फील्ड निकालोगे व्हाट इट विल बी के क्यू वन अपॉन R1 स्क्वायर, क्योंकि डिस्टेंस फ्रॉम पॉइंट P इज R1. इसके लिए निकालोगे तो के क्यू टू अपॉन R2 स्क्वायर. इसके लिए फॉर दिस R3 इट इज के क्यू थ्री डिवाइडेड बाई R3 स्क्वायर. दे आर नॉट डिपेंडिंग ऑन Q1, Q1 is not depending on Q2, Q2 is not depending on Q3. So that is also termed as the another statement of principle of superposition. ठीक है, so here you can write it as like this. Now here's another a question for you. Now two charges we have, 10 microcoulomb and minus 10 microcoulomb. They are placed at point A and B, that is separated by a distance of 10 centimeter. Now find the electric field at a point P on the perpendicular bisector of AB at a distance of 12 centimeter from its middle point. Okay, so this is a question for your homework. I will discuss this question in the next class. Try to solve it. I will making the figure for you. Here is the Q1, here is the Q2. Okay, this is point A, this is point B, and the distance between them is 10 centimeter. Okay, now we have a point here which is present at the perpendicular bisector, which means it is exactly at half of it. It is 5 centimeter, and here it is also 5 centimeter. Now field इससे क्या होगी, when you connect these lines ना, so it will be radially outward because this is positive charge. Q2 we are considering minus charge, so it will be towards this, है ना? Got it? Now you need to resolve this in the direction of x and y and take the resultant of it, you will get the value. Got it? So this is your homework. Please note it down. And if you are a good student of mine, you will definitely do this question and at least try to solve it. Okay? I'll definitely try this question, solve this question in the next class. ठीक है? आप अच्छे बच्चे हो, सब इसका स्क्रीनशॉट ले लो या फिर इसे नोट कर लो अपनी नोटबुक में. We will do this. ठीक है? Now, कर लिया सभी ने नोट? Everyone? JNV student, have you noted down? Okay, very good. Now the electric field lines. ठीक है? Now what is electric field lines? अभी हमें प्रॉपर तो नहीं पता क्योंकि Q कोई चार्ज है. If we have a charge Q here and another charge is experiencing some force, okay, we can say it is will be repulsive because both the charges are positive in nature. But how do we visualize these? So these electric field lines are the visualized image of the electric field or the line of forces. ठीक है? How we can imagine कि how this another charge particle is get repelled in this particular direction. So this will be done by this electric field line concept. ठीक है? So suppose there are multiple charges here. ठीक है? This is point A. Point A से कोई भी particular field is in this direction. Point B पे जो field है is in this direction. C पे जो field है is in this direction. Any random direction. So when we connect these lines, these dots, point A, point B, point C, so we get a curve, and this particular curve is termed as the electric field line. ठीक है? Which अब इसका फायदा क्या हुआ? ये हमारे पास कर्व आ गया इलेक्ट्रिक फील्ड लाइंस का. These are the different points we have, A, B, C. So if you draw the tangent at this point, you will get to know the direction of force. ठीक है? So that is the application of these imaginary electric field lines. When you draw the normal at any particular point, sorry, draw the tangent to at any particular point on the electric field line curve, you will get to know the direction of electric field. And if you get to know the direction of electric field, you can easily guess the direction of force. Okay. So electric field line is a curve that is drawn in such a way that the tangent to it at each of the point is in the direction of net field at that point. Okay. So as I've already told you that it is just the imaginary lines. There is nothing physical existence. You will not get to see these lines. Okay, these are the lines going. No, this is not going to happen. Okay. Now the properties. Property में सबसे पहले हमें पता ही है कि पॉजिटिव चार्ज से इलेक्ट्रिक फील्ड भी रेडियली अवे. So we can consider now this is positive charge. So radially outward will be like this. So these are the positive charge. Suppose a charge is present here, another charge. So what is the direction? Radially connect karo outward if it is positive. If it is negative, radially inward. Okay? Now, so here this is positive charge. Two other charges we have taken. These are the line of forces. F1, F2 repulsive. And in the direction of radial, so we can say that field start from the positive charge. है ना? क्योंकि अगर ये फोर्स इस डायरेक्शन में लग रहा है, देखो, क्योंकि पॉजिटिव चार्ज ऑलवेज रिपेल्स. Positive charge always repels, which means these line of charges are originating from it. ठीक है ना? इसे ओरिजिन थोड़ी कह दोगे. इसे इसे आप क्या कहोगे? Line are originating from this? No, line is terminating at this. And because negative charge attract the positive charge, so we can say that कि जो field lines है, which is inward, radially inward for negative charge, which means they are terminating at the negative charge and originating from the positive charge. ऐसा नहीं फील हो रहा कि ये इसी में से निकल के जा रही है. देखो, है ना? Which means positive charge से the field will be outward. Okay, JNV Shimoga, clear है? Because positive charge repel, so that is why the field will be outward. Got it? Now, if the negative charge is here and another positive charge is present, yeah, this question will be answered in this situation. Here we have two charges. This is F1. This is another charge F2. Both is attractive. You can say कि minus Q charge is attracting these positive charges, or this positive charges is attracting this negative charge. Vice versa you can say, है ना? So same way, which means that negative charge is what? Having radially inward the electric field. So this is the convention that we have taken. Okay, na? We measure the repulsion and attraction with respect to positive charge. So we have taken the reference of positive charge. Now we will take the another charges with respect to this charge. This is positive always, reference charge. So if we take the positive charge, it will repel. If we take the negative charge, it will attract. So positive को repel कर रहा है, which means it is has a direction outward, radially outward. ठीक है? And negative charge इसकी तरफ attract हो रहा है, which means the lines are terminating on it. Got it? These are the convention. Conventionally, we will take the reference of positive charge always. ठीक है? So always remember that they are starting from the positive charge and end at the negative charge. Got it? Now, and if there is a single charge, they may be start or end at infinity. अगर ये सिंगल चार्ज है तो कहीं पे भी जा सकते हैं, इंफिनिटी तक जाएगी, है ना? Two field lines are never cross each other. Suppose there are two field lines. अगर इन दोनों ने क्रॉस कर लिया, if they both cross each other, so at the point of junction हमने जाना ही है कि इलेक्ट्रिक फील्ड लाइंस इज दैट कर्व जिसपे if we draw the tangent we will get the direction of force. So at the point of junction if they are crossing each other, ठीक है, so there are two point of direction, either it in this direction or in this direction. At the same time कोई भी पर्टिकुलर चार्ज दो डायरेक्शन में फोर्स कैसे फील कर सकता है ना? क्योंकि these forces are वेक्टर, और वेक्टर हैं तो रिजल्टेंट होगा, एक पर्टिकुलर डायरेक्शन होगी फोर्स. So that is why they never cross each other. ठीक है? Because at the point of contact, they will have two direction of forces or electric field. Will not have a unique direction. ठीक है ना? और दूसरी चीज आप ये भी रख सकते हैं ध्यान में, magnitude of this electric field is represented by the density of field lines. यहाँ पे अगर आप देखें, if I draw a circle, only 3 lines is covering. If I draw the same length circle here, the number of lines increasing, which means here the field is denser, or denser mean stronger. So more is the number of field, more the field will be strong. So as you move towards the charge, the number of field lines will increases. ठीक है? So density पे भी depend करता है. More denser the region is of electric field lines, more is the electric field. ठीक है? More is the magnitude of electric field. ठीक है ना? This is the region of weak field and this is the region of strong field. Got it? तो इलेक्ट्रिक फील्ड लाइन की जो स्ट्रेंथ है दैट इज डायरेक्टली प्रोपोर्शनल टू द इलेक्ट्रिक फील्ड लाइंस. You can take that for example, this is positive charge, so line these arrows are representing the direction of charges. ठीक है? You can enjoy the visual, and if anyone has any kind of doubt till now you can ask, otherwise the lecture is being over. Thank you so much for being attentive and being responsive, and you guys are keeping your promise, that is very good. I'm glad. So thank you so much, guys. Any kind of doubt you can ask. Otherwise, the lecture is being over. Thank you so much. You can see as we are moving away, the length, this length is going decreasing, है ना? So which means the strength of the field is decreasing. चलिए, okay. Bye. Take care. Bye, JNVNM student. Bye, everyone. Take care of yourself. Bye bye.